Welcome to The Explainer. Today, we're going to pull back the curtain on what I think is the most critical, but also the most overlooked part of making software. It's the secret blueprint, the plan that really decides if an app is going to be a hit or a miss, way before anyone even thinks about writing code. So you've probably wondered, how does a simple idea turn into an app that you just can't put down? You might think it's all about amazing programmers or some slick design, but honestly, you'd be wrong. Every single great app starts with something much more basic, a deep, real understanding of a problem that needs solving. To really get this, let's follow a story. Let's meet Jack. He's a teacher, and he wants to make a local history project way more exciting for his students. He's got an idea for a simple photo sharing app, and he's going to call it iLearn.
Okay, so the goal here is pretty straightforward. Jack just wants his students to be able to upload old photos, share pictures they take for the project, and then talk about them in the comments. It's all about creating this fun digital clubhouse for his classroom's history project.
All right, so if we were the ones hired to build this app for Jack, where would we even start? Do we start sketching out screens or picking colors? Nope. The very first, most fundamental question we have to ask is, what exactly are we building?
Let's dive right in. The very first step is to make a list, a super clear, no room for confusion list of every single thing this app has to be able to do. We're defining its purpose by defining its actions.
Now, in the software world, these actions have a specific name: functional requirements. Just think of them as a concrete to-do list for the app. They define the what, the specific jobs it absolutely, positively has to do.
So for Jack's app, iLearn, this means a few things are non-negotiable. Students have to be able to upload photos and comment. A teacher, like Jack, needs to be able to check everything and moderate it. Oh, and it's got to connect with the school's existing login system, and of course, store all that data somewhere safe.
Okay, we've got our feature list, so we're done, right? We can start coding? Ha, not even close. Knowing what an app does is literally only half the story. How it does it, how it feels, how it performs, that's just as important, maybe even more so.
So now, let's move beyond what the app does and really focus on how it does it. This is where we start talking about the qualities, the constraints, the stuff that separates a clunky app from a truly great one. And you guessed it, these have a name too: non-functional requirements. These don't describe one specific button or feature. Instead, they're qualities the whole system has to have. They're the how well requirements, stuff like how fast it is, how secure it is, and how easy it is to use. For iLearn, this is huge, because the context is everything. Remember, the users are kids, so it has to be incredibly, unbelievably easy to use. And since we're dealing with children's data, security and privacy are an absolute must. Plus, it's got to work on the classroom computers and on their phones, and it can't crash right in the middle of a lesson.
And this quote just hits the nail on the head. This stuff isn't just a nice little extra. Getting this wrong is a huge reason why giant multi-million-dollar software projects completely fail. I mean, an app can have every feature in the world, but if it's slow or confusing or insecure, it's a failure. If iLearn is too complicated for a 7-year-old to figure out, then it is completely useless. Simple as that.
So this whole process of asking questions, of digging into the what and the how, it isn't just a messy brainstorming session. It's actually a very structured professional discipline. It has a formal name.
It's called requirements engineering. It's basically a formal process for turning those vague ideas into a rock-solid plan. It involves 4 key steps. You discover what people need, you analyze it all, you write it down very, very clearly, and then you double-check to make sure you got everything right. Of course, this is almost never a straight line. People often don't really know what they want until they see something. A teacher's priority might clash with a student's idea of fun. And, things change. You might be halfway through the project when a whole new idea comes up. It's a messy human process.
So after all that talking and analyzing, and maybe even a little bit of arguing, where does all this incredibly valuable information go? It has to be put down on paper, so to speak, in a formal document that everyone can agree on. Well, these needs are actually documented for 2 totally different audiences. On one hand, you've got user requirements, which are written in plain English for people like Jack. But then you have system requirements, which take those needs and translate them into super detailed, technical instructions for the developers who are actually going to build the thing.
And all of this, the functional stuff, the non-functional stuff, the user view, the system view, it all comes together in one master document, the Software Requirement Specification, or SRS. This is it. This is the official blueprint. It's the single source of truth for the entire project.
Which brings us to what I think is the most important point of all. The #1 skill in building amazing software isn't about being a coding genius. It's empathy. It's about the hard work of truly, deeply understanding the people you're building something for, their goals, what drives them crazy, and the world they live in.
So next time you're using an app that you just love, think about this. What are those invisible qualities, those non-functional requirements like its speed, or how simple it is, or how safe you feel using it that really make it great? Because I promise you, that's where the real magic happens.